Good morning everybody. In this video, we're going to be looking at an example of a circuit that uses everything we've been learning in the previous videos. But before we do that, I've got to show you two more components. This first component that I want to introduce you to is called a comparator, and this is how you would draw it in a circuit diagram. These inputs here don't really do anything except give the comparator power. It's these inputs and these inputs which do something interesting. The comparator is appropriately called a comparator because it compares the voltage of two inputs. If the voltage in X is less than the voltage in Y, then the output of our comparator is going to be 0 volts, or just matching ground. But if the voltage in X is greater than the voltage at Y, then the output is going to be 5 volts. And that's the basic function of a comparator. It's just to compare whether voltage X is greater or less than voltage Y. And just briefly, this is what a comparator might look like in real life, especially if you're a hobbyist. You have these through-pin ICs, and you can see the same inputs here in this IC. And for anyone that's looking at me funny because they don't know what IC means, it just means an integrated circuit, which means these little black boxes that you'll see in almost any circuit board. Usually they have a function that could be useful in many circuits, and so they sell them in these little packages. The next component I want to tell you about is a thermistor. In real life, if you're a hobbyist, they might look like this, and in a circuit diagram, you draw it like this. Now a thermistor is basically the same as a resistor, except its resistance doesn't stay the same, it changes. And it changes based on heat. Hence, thermoresistor, thermistor. So say for example, we're sitting at a cool 25 degrees, then perhaps the thermistor will have a resistance of 10 kilo ohms. But say if it gets slightly hotter, like 30 degrees, then maybe the resistance will be slightly lower. Maybe it'll be 8.06 kilo ohms. And as it keeps getting hotter, say 35 degrees, we might have a resistance of 6.5 kilo ohms. Using these components, I'm going to show you how to make a circuit that will make a light turn on when it's hot, and then turn off again when it gets cold. So we have a component here that has a changing resistance, and we have a component here that measures the differences in voltages. So our first step is to convert this changing resistance into a changing voltage. And how do we change voltages using resistors? That's right, we use a voltage dividing circuit. So if we place our thermistor here, and we look at the values we have before, we can see that the resistance will likely range from 10k to 6.5k. That means in our voltage divider circuit, if we have a 10k resistor here, then at 25 degrees, the voltage across here will be 2.5 volts, right? Because we've got two 10k resistors, and so half the voltage is going to be lost across all of them as we go from 5 volts to 0 volts. But as the temperature gets hotter, say to 35 degrees, then the resistance across the thermistor is only going to be 6.5 kilo ohms, which means the voltage is going to be 6.5 over 16.5, because that's the percentage of resistance coming from this resistor from here to here, times the total voltage across there, which is 5 volts, which is equal to something more like 1.97 volts. So we have a voltage divider where we know that the voltage gets smaller as the temperature gets higher, and we have a comparator here, and we have the light that we want to turn on here. So perhaps we can do it like this. We'll connect the light up to 5 volts, so it won't turn on unless we complete the circuit by introducing 0 volts here. We know that this comparator will output 0 volts when this is lower than this. And we can say when this one is lower than that, which is perfect for us because this one here, the voltage from here to ground gets lower as the temperature gets higher. So we can connect it to here, and all that's missing now is a voltage to compare this voltage to. So what we can do is if we bring back our chart, we know that at 30 degrees our thermistor is 8.0. We know that at 30 degrees our thermistor has a resistance of 8.06, and so we can create another voltage divider just like our previous one. So 5K 0V with a 10K resistor and an 8.06K resistor, as though that was our thermistor, but it's not. But it's that sort of represents our thermistor at 30 degrees, and the voltage that comes from this voltage divider is going to be the voltage that this thermistor will be at 30 degrees. So at 25 degrees, this is going to be 10K, which means we're going to get 2.5 volts out of here, and we're going to get something smaller, maybe 2.1 volts out of there, because if you have a 10K resistor and an 8.K resistor, it's going to be less than 2.5 volts. And when this is more than this, then the output from this comparator is going to be 5 volts. And because we've got 5 volts going down to 5 volts, there's actually no voltage across these 2 points. The difference in voltage is 0. But if it gets hotter and this resistance gets lower, it goes down to 6.5K, then the voltage coming out of this voltage divider is going to equal to, say, 1.96 volts, or say 1.97 volts, while this voltage divider remains 2.1 volts, which means that this here is lower than this here, and when this is lower than this, then our comparator will output 0 volts or ground. And this creates the difference in voltage that's needed to light up this light, and we'd get light. Now, this circuit is obviously a little bit messy, but there's a few ways we can clean it up. We've got 2 instances of 0 volts and 5 volts, and so rather than having them separately, we can sort of combine them. And then of course we need to bring this one over to here, and we need to give power to our comparator as well. We need to actually give it 5 volts and ground, like we saw at the start of the video. And all we really need to do now to complete the circuit is to put a 5 volt voltage source at the start. And there you have it. For anyone that's interested, this is the circuit that was shown in the book. This is exactly the same as what we've been through in the video. It's just drawn out a lot nicer. And now, you know how we make it.